Remember, take notes. Um, I do have homework that I want you to do at the end of this. Or I might ask you to just show me your notes for today. So make sure you're taking notes as we go. So today's called inverse functions. Inverse functions. Today we will quickly go over questions from Tuesday's homework if there was any questions. And then we're going to define what is an inverse function. Learn to identify an inverse function. And that's it for today. That's our three goals. So, for the homework on Tuesday, some of you sent that to me. I appreciate those of you who did, who got on it right away. Um, one or two people tried it yesterday, sent me their work yesterday. Um, so let's talk about that. Were there any questions? Here's the two homework questions. I gave you all two functions, number one and number two. Here's the function. F of x equals 5x plus 9. And then below, f of x equals negative 3x plus 4. And each one has a different domain. Your job is to plug in the domain values for x and find outputs or range for each one of those domain values. So does anyone want to go over these, or did they get stumped? Did they get stuck? Any questions, concerns? All right, let's see. Anthony, I know you just joined us, and I was just asking if anyone wants to go over the homework questions for Tuesday. Okay. All right. Well, then, if there's no questions, then everyone must be feeling fine and know how to do these, no problem. Let's do a quick warm up for their new work today. Here we go. Here's our warm up question. So let's start with this. Please write this down on your paper, and I want you to solve for k. Solve this equation for k. How do we solve it? We're going to combine like terms. Like terms. And then we want to get k alone. We want to isolate the k. Notice that we've got k's and b's in this problem. Only the k's can add together. And we can't add the b number to the k or to the non-variable number. All right, take another minute and I want to see what you guys got. And here's another hint. It's not going to be a whole number answer. It's going to be just another expression with a b in it and some numbers. Okay. I think that's probably enough time to have something. So let's see. All right. Does anyone finish it completely and think they might have a good answer for k equals something that they'd be willing to share? Anybody? Okay. Did anyone get part of it started and they just didn't finish? Joseph, would you mind? Would you be willing to share what you did get?
I'm still working on it right now.
For sure. Okay. Well, I'll let you finish. You know what? We'll just wait another like 30 seconds and let everyone have another some time to finish. So remember, we want it to be at the end k equals something. K equals something. That's the mystery. Is what is it equal to? Okay. Now, with a little more time, does anyone have either a final answer they'd like to share or even just a partial? Like, did you get started and then got some of it done, but maybe didn't get K all by itself yet? Please, anyone be willing to share what they got? No? Okay. Well, let's talk about it. You know what? Do this for me. Do this for me. If everyone could just show me your notes and show me that you have something started, even if it's not finished, you're not going to be in trouble. I just want to see that you gave it a shot to solve it. Joseph, thank you, sir. Got that. And I'm scrolling through. Hold it up. Savannah, thank you. Maria Celeste, I see that. Thank you. All right. Anyone else? All I want to see is that you gave it a shot. Who is that? Anaya. Sorry. Thanks, Anaya. There we go. Thank you. It was covered up. Something on my screen. Okay, folks. So come back with me if you haven't already. Let's just go through this together. You can check your work against what I'm going to do. Okay, so we want to combine like terms. Can anyone tell me what are the two terms in this problem that are like terms that we can add or subtract? Please.
7.
Go ahead.
3 and 7K.
Yes, yes. Anaya said the 3K and the 7K. Totally. We're going to add those together, but just uh, one issue to keep in mind is that one of those numbers is negative. It's negative 3K and a positive 7K. So just keep that in mind. It's kind of like saying negative 3 plus 7. Okay. The math we're going to do without the K, the math of adding like terms is going to happen with just the coefficients, just the numbers. So negative 3 combined with positive 7, if we do our battle between the negatives and the positives, there's going to be 4 left over. And because the 7's bigger than the 3, right, then there's going to be positive left over. So our answer is 4K. So 3K plus, or negative 3K plus positive 7K, 4K. So back to the actual problem. Those two are combining to become 4K. Woohoo! And it's positive, right? Because um, There was more positive when we started. Bring down the rest of the stuff we haven't dealt with. We've got 3 plus 4k equals 5b. Now, this is a little tricky, but I wanted to start today with a challenge. We want to get k all alone. So what's happening to the k? Think back to Unit 1 and how we were solving equations for our variables. Identify what's happening to the k and then do the opposite. So we want to undo this plus 3. So I'm going to do minus 3 to both sides of my equal sign. That moves my 3 away from the 4k. It gets it out of the way. We want to get it over on the other side of the equal sign. But now it's negative. Notice that? It's not the same sign as it was originally. It's negative 3 now. And then we want to undo this timesing of 4 to the k. So to undo multiplying, we want to do the opposite, divide 4. We're doing it to both sides of our equal sign. So on the left side, 4 over 4 cancels. That was on purpose. So what do we have here? We've got k equals 5b minus 3, all divided by 4. Alternatively, you might have written this down. K is equal to 5b over 4 minus 3 over 4. Either one of these would be okay as an answer. Either way, the whole right side of the equals sign is being divided by 4. Now we're going to be doing some more of this today. Excuse me. And that's why I wanted to practice solving equations for one of the variables. Any questions, folks, please? Concerns? No. Okay, silence. Then let's look at inverse functions. So what in the world does inverse function mean? So back up with me for a moment. So think back to what we did last week and this week about our regular functions, right? Just normal, plain old functions have inputs and outputs. We plug in numbers usually for x, and then we get out a paired up number with that, right? The domain is the input. It's the list of inputs, and then the range is the list of outputs. This is normal functions. Before I define inverse function, I want to make a table for this example function. So example 1, make a table for f of x equals 2x plus 1. So just a reminder, how do we do this? We're going to make an x column, and then we're going to make a f of x column. This is our function notation. The f of x is just like another way to write a y, okay? This is going to represent our range numbers. Now, it doesn't tell me what I should use for my domain or my range, right? So I'm just going to pick some numbers that are around 0. So let's do 0, 1, 2, and 3 for my inputs. So let's plug in 0. So f of 0 is how we say that, is equal to 2 times 0 plus 1. 0 times 2 goes away, and we're left with just good old 1. So f of 0 is 1. That's my output when I plugged in a 0. So there's our first range number. Cool. Now we're going to plug in 1, and then we'll do 2, and then we'll do 3. F of 1. 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So f of 1 is 3. Okay, now I'm going to do f of 2. 2 times 2 plus 1. We get 4 plus 1, that's 5. And lastly, we'll plug in a 3. So f of 3, 2 times 3 plus 1. 6 plus 1, that's 7. Okay, so there's a little table that we made for the function f of x is equal to 2x plus 1. So notice looking at our table that our inputs using the function go over to the output on the right. That's kind of like how we use tables already, right? Inverse functions, I'm going to erase that work. Inverse functions are, think of them as functions that go backwards. So every function, every normal function that has an inverse, the inverse function goes backwards, where if we were to plug in the range for this function, it would take us back to the original domain number. So for instance, if I knew what the inverse of 2x plus 1 is, this function, f of x is equal to 2x plus 1, well, then I would plug in 1, 3, 5, and 7, and it would spit out for an output 0, 1, 2, 3. So let's add that to our little diagram on the other side. Let me change my color real quick so you see the difference. I'll change it to red. So if I knew the inverse, oh, that's orange. The inverse function, you would plug in these numbers and it spits out the other half. It's kind of like the evil twin of an original function. F of x equals 2x plus 1 in this example is our original function. The inverse would take those outputs and then give you as outputs the original inputs. I know that's kind of confusing, but that's why I wanted to show you with a table. And now let's actually find the inverse function for this 2x plus 1. And before I do that, before I move the screen, any questions or concerns right now? Anything, please. Here's our takeaway so far. Inverse functions go backward from the outputs to the inputs. It's like the reverse of whatever the first function did. No notes. I mean, no comments or concerns. Okay, let's now find the actual inverse for this example. Okay, so how to find inverse functions. And then I have here, find the inverse of f of x equals 2x plus 1. That's the same equation we were just working with. Now below and on the left, here's our steps. So go ahead and write these down. Step 1 is to swap x and f of x, meaning we're going to change places in the equation. And then, once we've swapped them, we simply solve the equation for f of x, meaning make sure the f of x is all by itself, isolated. Isolate the f of x, just like we did in our warm-up, right? We wanted to isolate the k. And now f of x, it might look a little weird and a little scary, but remember, all it is like a y. I want you to treat it like it's its own single entity. It doesn't mean f times x. It means the output. So let's do this now. I'm going to swap x and f of x in my function equation above. Okay, so there's my function, but I swapped x with f of x. Notice how those have changed places. And now we want to solve the equation for f of x, meaning get the plus 1 away from my f of x and get that times 2 away from it. We want to undo those actions. So we're going to subtract 1 from both sides of the equal sign. So on the left, x minus 1, those aren't like terms, are they? So those are going to stay as just x minus 1. They don't combine. X minus 1 is equal to 2 times f of x. And now how do we undo timesing of 2? Divide by 2. So divide by 2 on the left and right. And now we've done it. F of x inverse is equal to this function, x minus 1 over 2. And here's one other thing I need to mention is inverse functions are designated with this little -1 symbol. So let me, I'm going to write that bigger in the bottom right. F -1, that little -1 on top, that's just a symbol telling us F inverse. And how you say this is F inverse. So that's a clue that says, oh, this is an inverse function of some other original function. So on the top, this is like our original function where we started, and then we made or found the inverse of that function below. F inverse is x minus 1 over 2. Okay, our original was 2x plus 1, and then the inverse function we just found, x minus 1 over 2. And then our original table that we did, that was 0, 1, 2, and 3, and it went to 1, 3, 5, and 7. So let's check out that table and compare our two functions, the inverse and the original. Hang on. Here we go. So just to continue with that first example, our original function was this. Then we used our two steps and we solved for the inverse. And that was this one, F inverse x minus 1 over 2. So just look at those two equations with me for a moment and notice that there's some similarities. They each have a 2 somewhere and they each have a 1 somewhere, right? Some of the signs are different. And you might notice that the actions are all opposited. So instead of times 2, like we see on the left, we actually have divide by 2 on the right. And instead of that plus 1, we see a minus 1. So everything is inverted. Everything is opposite of how it was originally. Let's compare the table. Here's the original table we made. And we had 1, 3, 5, and 7. So the inverse table, I'm going to, let's do the inverse table. So for the inverse, if we make x, and then I'll write this as f inverse of x. So I told you initially that the inverse function will like go backwards. So I'm going to list off my domain numbers as the original range numbers. So I'm going to try these ones, 1, 3, 5, and 7 for my inputs. And we should see that when we plug these numbers in, we get the original domain. We should get 0, 1, 2, 3. So let's test this out and see what we get. I'm going to change my color quick. Let's plug in 1 for x. And we should get a 0. 1 minus 1 is 0. 0 divided by 2 is 0. So we did get 0. Cool. Let's try plugging in 3. We should get a 1. I'm looking at my left table to see what that should give me. So I'm plugging in 3, and I'm hoping that it gives us a 1. 3 minus 1 over 2. 3 minus 1 is 2. 2 divided by 2 is 1. Cool. Now let's plug in 5. 5 minus 1 over 2. 5 minus 1 is 4. 4 over 2 is 2. Cool. It's working. It's always giving us the original domain number when we plug in that original range number. Let's try the 7 just to see it. F inverse of 7, 7 minus 1 over 2, 6 over 2, and that's 3. Okay, sorry that's kind of cramped for my work on the right. Now, the point here, folks, is that there's not one inverse function like that exists, period. There's an inverse for almost all the functions that exist. Every different function that we come up with could have its own inverse, and they'll be unique. So these two functions that we have, the original and that inverse function, those go together like evil twins of each other. They do the opposites of each other. All right, let's look at a couple other examples. I'm going to go back. Here's example 2. And we're going to use our steps to find inverses of the different equations. So example 2, find the inverse of f of x equals 1/3 x plus 7. The two steps are swap x and f of x. Swap them. And then solve for f of x. It's just those two steps. Okay, so swap x and f of x. So here we go. X equals 1/3 f of x plus 7. So all we did here was we swapped the x and the f of x. Then next step is get f of x alone. Solve for it. Isolate it. What are the two things that you see happening to the f of x? Can anyone tell me two operations with numbers that are happening to the f of x? Something's being added to the f of x and something's being multiplied to the f of x. Does anyone see it?
Yes, 1/3 is being multiplied to f and x. I don't know how to say it.
No, you're doing good. That was perfect, Savannah. That was Savannah, right?
Yeah,
Thank you, Savannah. Yeah. 1/3 is being multiplied. Since you're with me, what's being added to it?
7.
7. So those two things you just said are what we have to undo now. Thank you, Savannah. We're going to undo this 1/3 times, and we got to undo the plus 7. The plus 7 is the easier part to start with. Let's do that first. We're going to subtract 7, subtract 7. Remember, folks, when we're solving an equation for any variable, in this case, we're solving it for f of x. We're doing our actions to both sides. Okay, so always, always, always both sides. So 7 minus 7, that goes away. And on the left, x minus 7. Copy down what is left. We've got our 1/3 times f of x equals x minus 7. We're not combining x and 7, right? They're not like terms, so they're kind of stuck that way. X minus 7. Now, this is a little tricky. When we've got to divide by a fraction, things can get really confusing and really weird, and I think unnecessarily. So what I've told you this before, we've talked about it before. Instead of dividing by a third, okay, instead of doing the opposite of that, I'm going to multiply both sides by whatever's in the bottom of that fraction. this is going to undo what we need undone and clean it up real fast. So instead of dividing by a third, I'm going to multiply the right by 3, and I've got to multiply the left by 3. So I'm multiplying the entire left side by 3 and the entire right side by 3. This clears out the fraction immediately. 3 divided by 3 just gives me the f of x now. On the left side, I've got some distribution here. I've got to multiply 3 to everything you see. So 3 times x, 3x, and 3 times 7, 21. The only other thing we should do is make sure to put our little -1 symbol, icon, with our f of x so we know this is an inverse. So here's our final answer. F inverse of x, and I'm going to write that below. This is how we say it. F inverse of x is equal to 3x minus 21. And just visually inspect it. You should see some of the same things there. But this time, it's a little different because we had that, if you look back through your work, we did 3 times 7, and that's where the 21 came from. So we don't see a 21 on the original and the inverse this time. But we see where it came from. It's because we had that 7, and we had to multiply everything on the left side by 3, and that's where the 21 came from. So and then we see 3 times x, and that's very similar to 1/3 times x. Those are the opposite. It's like x divided by 3, x times 3. Now, I'm not going to make us do a table this time to check it, but that's the steps of finding the inverse. We'll do more like this, but I want to, before we lose too much more time, I want to talk about inverses in our other formats. I want to talk about inverses with tables a little more and with graphs. So I took this problem from your mastery test or from the practice. This is an example where it might be best for you to just follow along with me, think about the problem, talk with me about it, engage with it. You don't have to copy down all these graphs, okay? I don't think that would be a good use of your time. But can we figure out, excuse me, can we figure out the inverse of this original function given to us above? This is our original. Can we find the inverse by looking at the graph? I think we can. I'm going to change to purple here so it kind of stands out from the other colors. So we know the original function above. We also know that inverses have like flipped tables from their original functions, right? So let's do this. I look at these 4 different options for the potential inverse graphs. And they're all kind of around the same area. They're all pretty close to the origin, pretty close to the 0, 0 area of the graph. So I'm going to make a table for the original function. I'll do that above here for just a few points. Let's see. Let's do 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And we'll do this quick. The function itself is short and sweet, x plus 4. So it's all the input numbers added to 4. So plug in 0, we get out 4. Plug in 1, we get 5. Plug in 2, we get 6. 6. And then we should get 7 and 8. So there's our table for the original. So now to identify the inverse graph, well, that's just like a table. Let's make this a different color next to it so it stands out to you, hopefully. Okay, so the inverse graph is going to be the reverse of these inputs and outputs. So without even finding the inverse equation, because that's not necessarily going to help us with the picture of the graph below, the table of the inverse will be the flipped version of the original table. So 4, 5, 6, 7, 8 should go to 0, 1, 2, 3, 4. Okay, so let's use this new red table and see if we can find anything useful comparing it to the ones below. So 4 goes to 0. X is 4. Our height, the y, is 0. Let's see. So for option W here, the first option, at 4, comma 0, it's right here. Our line isn't even on there. So we can rule this out. It's not W. No, not this one. X at 4, comma 0, again, same position. The line isn't even on it. So it's not this one. No. So we've ruled out W and X. If you look at the next two options, there's 4, 0, the line is on it. And here's 4, 0, the line is on it. So it could be either of those. It could be Y or Z. Let's see. Go back to your table. 5, comma 1 is on the table. So that's 5 to the right and up 1. So if we look at graph Y and graph Z again, 1, 2, 3, 4, 5, comma 1. Hey, check that out. This has the second point. And if we look at Z, 5, comma 1 right here, well, the graph is not on it. The red line is not on it, so it's not Z. That means it has to be this option. So this is the graph of F inverse of X. Graph of the inverse. How did we find this again? We made a quick table of the original function. We made a flipped table because we know that the inverse is everything from the original flipped, switched around positions backwards. So I just copied that down, but in backwards form. And then I compared my inverse table to the options below. So feel free to take a picture of this if you want to. I'll keep it up for another 10 seconds. But I didn't want you to copy all these different graphs down. I think that might take too long and be too hard. And not the goal. Okay, I think we've got a couple more different types that we might encounter. Okay, another problem I pulled from the mastery test or the practice. Read this with me. This set of ordered pairs defines a function. So this list of points, this is our original function here. Original, OG function, okay? So remember, this is a x's and y's because they're all in their own little parentheses, right? So this is also a table if we needed it. We could turn this into a table, and they are not even showing it as f of x. They're just showing it as y. Interesting. So our original table, I'm going to make a table out of the list they gave us. The first point is negative 49, 7. Then we get negative 56, 8. Then we get negative 63, 9. And then finally, negative 70, 10. Okay, so all we got to do is compare our original function table above in red to those options below and see which one is a flipped version. So we should see like 7, 8, 9, 10 for x, negative 49, negative 56, etc. for y below it. So it looks like it could be A and it could be C because those have 7, 8, 9, 10 for x. All right, then we want to see negative 49, negative 56, etc. below. So if we look at A, this is it. This has the exact same values, but all switched. C has them made positive for some reason. That doesn't make sense. There's nothing about an inverse that says everything changes to positive. The rule is all the inputs become outputs and outputs become inputs. That's what the inverse is. It does the opposite of the original function. So it's not C, it's A. Because we can compare that to the original points given to us above. Okay, it's 12:45 and someone's trying to join now? All right. I'm going to stop real quick and I want to see thumbs on how people are feeling so far on this idea of the inverse function, okay? We'll do a little more practice. Anthony R., thank you, sir. I see that. Savannah, thank you. Appreciate the feedback. Anaya, I see what you're doing. I appreciate your feedback, Anaya. And Maria, thank you too. How are the rest of you feeling? Alyssa, you just got here, so you don't have to vote. But Levi, Joseph, Brooke, Victor, how are you all feeling? Levi, okay? Okay, thank you for the feedback. And Victor, thank you, sir. Joseph, I see that. Brooke, are you there? How are you feeling on this idea of the inverse function so far? And then the rest of you.
Sure.
Oh, sorry to cut you off. Not sure yet? Okay, appreciate the feedback. How about Billy and Moose, Philman and Davey? You guys with me? Are you there? Billy, Moose, Philman, Davey. Interesting. All right. Well, thank you to those of you who are following along and giving me feedback. I really appreciate that. Let's see. I've got one or two more examples, and then today's homework was going to be just 3 functions given to you, and then find the inverse. But before we do that, let's do another example. We've only done like 1 or 2 of these so far. Okay, example 5. Find the inverse of this function, 3 minus x over 5. F of x equals 3 minus x over 5. Reminder, what are the steps to find the inverse? It is swap x and f of x, and then solve for f of x. That's what we're doing. And then step 3 is make sure to just label your new one as f inverse. Should have put that in my original steps, huh? Label the new function f inverse, f negative 1. All right, let's do it. So there's our steps. We're going to swap x and f of x. Like so. Okay, now we want to undo all the stuff that's happening to f of x and get it alone. Now this is a tricky one. I wanted to give you a tricky one. Any thoughts on what we can do first here? We've got to undo the 3, and we've got to undo that division of 5. What would be best? Any ideas? Any thoughts?
Maybe since it's like a division, you could multiply 5 on both sides.
Totally. Anaya, thank you so much. If we try to get rid of the 3 first, it's going to become messy because I'm going to subtract 3 from both sides like this. But then I've got this fraction. Just don't copy this down yet. Just watch me for a sec. This gets really messy. It's so difficult. Now I've got a fraction with 5. I've got to turn my 3 over here, the new guy, into a fraction. Oh my gosh, this is too much extra work. So what Anaya mentioned doing is what I think we should do first, because it'll clear out the fraction from the beginning, make it go away. I like that much better. So let me delete all my junk. Now there's nothing wrong with trying both approaches, okay? You can always do the other approach first, but um, in math, we really do want to find the easiest, fastest way to do a problem, even though you might not notice that. It might seem like I'm always trying to take a long time. That's just me. That's not all math, okay? So Anaya said times by 5. Let's clear that 5 out first. I like that much better. X times 5 equals, and on the right, 5 over 5 cancels out. So we're left with 3 minus f of x. Okay, now we can subtract 3, and it'll actually, work with or add to the positive 3 that we already have there. So I'm minusing 3 from both sides. And while we're at it, folks, I'm going to write this as 5x instead of x5. So 5x minus 3. Remember, they're being multiplied, right? So it doesn't matter if I write it as x times 5 or 5 times x. And we usually write our coefficient before the variable. So I'm going to write it as 5x minus 3. On the right side, positive 3 and negative 3 cancel. So we're left with negative f of x. Remember, it's 3 minus f of x, right? So that minus is still part of the f of x's identity until we make it go away. Until we do something about it, it's still there. Okay, so last step is we want it to be positive f inverse, right? Or f of x, not negative. So we can multiply everything left and right by negative 1. So last time I wrote it as like, I put a parentheses around the left side and distributed. The same thing is just to multiply every single term you see by that number you need. In this case, negative 1. So now this becomes negative 5x plus 3. Basically, we're just changing the sign of everything. Equals positive f of x. And now we're done. We finally, thank goodness, got the inverse. And we're going to call it f inverse with the little symbol. So let me rewrite that. I'll make it bigger so you can see. F inverse x equals negative 5x plus 3. Done. It's not too bad, but it is going to be a lot of extra practice and extra work with solving equations. We have to swap x and f of x and then solve for f of x. So it is going to be a more practice with solving equations for a variable. Okay, we've only got a few minutes. Let's try one more example and then we'll stop for today. I do have homework problems I want you to do on paper, and then send me your work, your answers. All right, here's another one. Just look at it with me. Don't bother copying all this down, please. Take a picture if you like. Example 6. Consider the function represented by this table. So here's our original. Which of these tables below could represent the inverse of function f? So if the starting one on top, f of x, that's our original, we're trying to figure out which of the tables below are the inverse. Only one will be the inverse. And honestly, I think this is even better than when it's an equation, because all we got to do is look for the flipped table. All my x's become f of x's and vice versa. So just a visual inspection, the first option, the R of X, number 1 here. Well, I should see -21, -9, 3 in the domain. I should see my original outputs over here, but I don't, right? These are all other things with signs flipped around. So this is not the answer. We can rule it out because it doesn't have the right inputs. We're looking for these -21, -9, looking for these as our inputs. Option 2, P of X. Hey, this is promising. -21, -9, 3. That checks out. Are the other set of numbers, is that the original domain? Yes, it is. Cool. So if you're comparing number 2 table with the original f of x above it, notice that the entire domain and range are just swapped out. That's exactly what we're looking for. So number 2 is our answer. P of x is this. They're calling it P of x. And notice, by the way, that this is what I tried to point out on Tuesday with you all, is that with function notation, it's oftentimes we just call them a different letter, right? So R of X is one function, P is the other, Q is one, S is a function here. So anyways, this is just another example of why function notation is useful. They just all have a different name. All right, I saw a chat in the comment. Awesome. Maria Celeste, high five to you. You got it. Thank you for putting that in the chat. All right, folks, so let's copy down these problems. Here's our homework for Wednesday. Oh, wait, I made this to have it for yesterday. My bad. This is for Thursday, the 14th. Inverse function homework. So please label it inverse functions, and then it's these 4 problems. Find the inverse of each function. Tell me if you can't read it or if you have any questions on it right now. For number 4, I need to make a table here. So let's have, here's our number 4. I'm filling it in. So for number 4, you're just giving me the table of the inverse, not like an equation. For the first 3, I want you to try finding the actual equations of the inverse. So you've got the weekend for this, obviously, but try it today and tomorrow. And if you have any questions, you can ask me on Google Chat or on Remind. And then remember, Brandon has 2 hours of extra math time tomorrow from 10 to 12 every Friday. All right, let me just copy down real quick who's here and who's been participating, and then I'm going to let you all go. So just hold on a sec before you go. So I know Savannah's here. Victor. Yes, Victor's here. And Moose is here. And Levi. Tiara was not here today. Alyssa's here. Alyssa, thanks for joining.